Number 2, we have another reaction that we're given in a delta H reaction. This reaction is exothermic. So I know the temperature of surrounding water is going to go up. Again, that's something you need to memorize. Okay, for B, how much heat is absorbed or released when 13 grams of water are produced? 13 grams of H2O. The molecular weight of H2O is 18. So 13 divided by 18 gives me 0.72 moles of H2O. In setting up my proportion, heat of reaction up here. Since I have the grams of water, I want to use the coefficient of water. 104.1 kilojoules is for 2 moles of HCl. How much energy comes out when we have 0.722 moles? So I'm going to take the 0.722 I have in my calculator, multiply by 104.1 and divide by 2. That gives me 37.5 kilojoules. Absorbed or released, again, based on exothermic, it's released. For C, that amount of heat is transferred with water. I'm going to find final temperature, similar process to above. This number has to be converted to joules before being plugged in there. From the numbers I have in my calculator, that'll be 37580. If you round it differently, that's absolutely fine. The mass of water is 350. Specific heat of water is 4.18, and I'm going to solve for delta T. And I get the change in temperature to be 25.7 degrees Celsius. The question's asking me for the final temperature, starting at 40. I know since this reaction's exothermic that things are going to get hotter. So if we're starting at 40 degrees and I'm getting hotter by 25.7 degrees, that'll give me a final temperature of 65.7 degrees Celsius. This next part of the problem is still based on the same reaction, and my reaction was 2HCl plus MgOH2 gave me 2H2O plus MgCl2 and had a delta H reaction of negative 104.1 kilojoules per mole reaction. Okay, so for D, now I have 20 grams of MgOH2. I need to get the moles of that. The molecular weight of MgOH2 is 58, so 20 divided by 58 gives me 0.345 moles. Same reaction, so I'm using the same heat of reaction. But now, since I have the moles of MgOH2, I'm going to use the coefficient of MgOH2 there. Solving for X, I get 35.9 kilojoules, still released, still an exothermic reaction. For D, same idea. For E, same idea as above. I'm going to convert that to kilojoules. From kilojoules to joules equals mass Cp delta T. So 35900 divided by 600 and divided by 4.18 gives me 14.3 degrees Celsius. Once again, because it's an exothermic reaction, I know the water's getting hotter. If I start at 10 and I get 14.3 degrees hotter, it'll give me a final temperature of 24.3 degrees Celsius. Make sure you're putting units on the answers to your questions.